So here we are going to discuss types of thermal expansion and their mathematical expressions. As we've discussed in very detail that there are three types of thermal expansion: linear thermal expansion, volumetric thermal expansion, and superficial expansion. So here, first of all, linear thermal expansion, we are going to explain it mathematically. So for this, we are going to consider a metallic rod, a thin metallic rod of length L1, like this. Considering the length of metallic rod is L1 and before heating the initial temperature is T1. After some time it is heated, and due to the heat the temperature increases and the metal expands, and there is some increase in length which is shown here by L2. So the original length is L1 and the change in length, the final length is L2, and the change in length is delta L. This is delta L. Okay, मैंने L लिखा है. So this is delta L. Mathematically we can write here the change in length is L2 minus L1. The change in temperature is represented by delta T, which is T2 minus T1. According to linear thermal expansion, it says that the change in length is always directly proportional to the original length. As the original length increase, the change in length is also increase. तो मेटल की रॉड अगर जितनी ज़्यादा उसकी अपनी लेंथ होगी उतना ही ज़्यादा उसमें एक्सपेंशन होगा, क्योंकि उसके ज़्यादा उतने ही उसके हीट के साथ साथ उसके साथ एक्सपेंशन शो करेगा वो. फिर एज द original length increases, as the temperature increases or the change in length also increase. ये भी दोनों डायरेक्ट रिलेशन शो किए हैं. डेल्टा एल इज़ डायरेक्टली प्रोपोर्शनल टू L1 original length, and delta L is also directly proportional to delta T. As the temperature increases, the change in length is also increases. By combining these two equations, we get delta L is directly proportional to L1 delta T. Okay, delta L is directly proportional to L1 delta T by combining these two. Now you know that we are going to replace the sign of proportionality with the sign of equality and a constant. Here the constant is alpha. ये proportional का sign नहीं है, ये मैंने alpha बनाया. So delta L is equal to alpha L1 delta T. What is alpha? Alpha is the coefficient of linear thermal expansion. Alpha is the coefficient of linear thermal expansion, means increase in length per unit original length and per degree rise in temperature is called linear thermal expansion. I am repeating again, increase in length or change in length per degree original length and per degree rise in temperature is called coefficient of linear thermal expansion, and this coefficient of linear thermal expansion is different for different metals, but it is a constant quantity. If you want to find out the unit of alpha, coefficient of linear thermal expansion, या मैंने छोटा सा कि आप इस तरह भी find out कर सकते हैं. The unit of L is meter, and the unit of absolute temperature is Kelvin. यहाँ मीटर एंड मीटर कैंसिल होगा तो आपके पास बचेगा 1/k. You can write it like Kelvin inverse. Now this is the final equation. L delta L is equal to alpha L1 delta T. But if you need delta L, if you need to change delta L into L2 minus L1, because delta L क्या है, L2 minus L1 हमने बताया. तो अगर आपको L2 कहीं फाइंड आउट करना पड़े तो उसके लिए भी फॉर्मूला हमने यहीं अरेंज कर लिया है. खुद भी कर सकते हैं आप. अरेंजिंग फॉर L2, सो डेल्टा L की जगह हम क्या लिख सकते हैं, L2 minus L1 इज इक्वल टू अल्फा L1 डेल्टा T. इफ़ यू वांट टू फाइंड आउट L2 तो हम L2 यहाँ पे रखेंगे और माइनस L1 को उस तरफ भेज देंगे, तो फॉर्मूला विल बिकम L2 इज इक्वल टू L1 प्लस अल्फा L1 डेल्टा T. और यहाँ L1 एक दो दफ़ा आ रहा था तो हमने इस फॉर्मूले को L2 इज इक्वल टू L1 कॉमन करके 1 प्लस अल्फा डेल्टा T. ठीक है. तो दिस इज़ योर लास्ट इक्वेशन फॉर लीनियर थर्मल एक्सपेंशन मैथमेटिकली. ठीक है, पर इक्वेशन यहीं ख़त्म हो गई है आपकी. मगर इफ़ द क्वेश्चन इज़ if the L2 you are going to find out in any question, then we arrange the formula like this: L2 is equal to L1 L1 plus alpha delta T.